An introduction to current sources. Current sources are less familiar than voltage sources like batteries and AC wall power. Current sources usually are buried, unseen, inside electronic circuitry. Learn what they are and how they are designed. Most of us understand voltage sources. Whether you plug only one device or several devices into your wall outlets, the voltage stays the same. When you put 2 or 3 batteries in series, you double or triple the voltage. Measuring voltage is easy. If you have a voltmeter, set it to the proper scale and put the 2 probes into the wall outlet, carefully, of course, or across the battery. Current, however, is less familiar. Even some technical people don't really understand current or know how to measure it. Even fewer understand current sources or even know they exist. In this article, let's quickly review the basics of current before jumping into current sources. Voltage vs. current. Diving in, let's look at Figure 1, which compares electric current to water flow. To measure water flow, a flowmeter is added in series in the pipe. Likewise, to measure current, an ammeter is added in series, as shown in Figure 2. The circuit must typically be broken, a wire cut, or a connection opened, to add the meter. This is different from voltage, which can be measured by just touching the meter probes between the 2 measurement points. As an aside, there are clamp-on current meters that wrap around a wire and measure current indirectly by measuring the wire's magnetic field. These do not require breaking the circuit. These are analogous to clamp-on flow meters that use an ultrasonic beam to measure water flow. Current source vs. voltage source. Next, take a look at Figure 3, which compares voltage and current sources. Adding loads in parallel to a voltage source increases the current but does not change the voltage unless the total current is more than the source, generator, or battery can supply. In the example of a current source shown in Figure 3 bits, the loads are added in series. If additional light-emitting diodes, LEDs, are added, the resistance changes. If the motor is removed, replaced with a short circuit, the voltage will change, but not the current. The current will stay constant unless the total load voltage exceeds what the current source can supply.